We have already used iterators some in previous lectures, but just to refresh, let's see one really quickly. So we'll create a vector and we'll use the vec macro and we'll just say 1, 2, and 3. And it helps if I use the correct brackets. And then we can say for val and vec.iter print line and then print the val that is in the iterator. So we'll say cargo run and we see 1, 2, 3 being printed out. So all iterators are going to implement a trait named iterator, which is defined in the standard library. The trait looks like this. So we have trait iterator, and then we're going to have type item, and then we have fn next, which is going to be a reference to the mutable self, and it's going to return an option of self item. And then there's many default methods available to us once we implement next. So item is the type of value the iterator produces, and the next method either returns a sum with a value contained in it, or it's going to return none to indicate the end of the sequence. And then we also have the IntoIterator trait. And any type that implements IntoIterator is an iterator because it's something we can iterate over by calling the IntoIterator method. So let's look at an example of this. And I'm just going to comment that out. And we'll comment this out as well. So we'll create another vec called vec2. And in here, we'll do the same thing, 1, 2, and 3. And then we'll say let mute iter equals a reference to our vec. And then we'll say IntoIterator. And then while let sum v equal iter.next, which is the method given to us here because we created an iterator this way by calling the IntoIterator method, we can now print out the values inside of sum v. And if we run this, we expect the same output of 1, 2, and 3. Great, which is exactly what we got. So, just to clarify, an iterator is any type that implements the iterator trait, and an iterable is any type that implements IntoIterator. Now remember, last lecture I said closure sign when using iterators. So let me expand on that. So we will comment all of this out. And up here, I'm also going to just go ahead and comment all of this out, as well as that, and as well as these. So I want to create a new struct called item, and in here I want it to be a string that has a name, and we're also going to give us the derive debug trait here as well. So now we're going to create a function that's going to be called check inventory, and we're going to accept a vector of items, and then we want to check to see if a product exists by accepting in a string, and then we'll return back a vector of items. And then in here we want it to be items.IntoIterator iter, so create an iterator. And then we want to filter, so now we have another iterator. So as we see here, it creates an iterator for us. And this is where our closure is going to really help us. So we'll accept in a parameter, and then we want to check to make sure that name equals the product. And then to return it back to us in a vector, we want to collect on this. So in here, we'll create a vector of type vec_item, which is going to just be a new vector. And so now we'll push in some values. So we'll push in an item, and then in here our name is going to be a string from, and we'll have a coat in this case. So now let's push in a couple more additional items. We'll have and we'll add in our semicolons, and now we'll have a shirt. We'll have some shorts, and we'll have some shoes. So again, a very simple little example for us to kind of understand what's going on. So then we'll say let checked equals check inventory. We'll pass in our vec, and then we want to see if we have a string from shirt. So we want to see if we have a shirt in stock in our inventory, and then we will print out what is returned to us. So let's run this and just see what happens. So we see that we have an item with the name shirt returned to us. So let's go back up here and kind of look at what we did. So we used an IntoIterator to create an iterator that's going to take ownership of the vector, and then we call filter to adapt that iterator into a new iterator that only contains elements for which the closure returns true. The closure captures the product parameter from the environment, and it's going to compare the value with each item we created and only keeps the item we specified, which in this case was a shirt. So it's only going to keep the item that is a shirt. And then we call collect to gather the values returned by the adapted iterator into a vector that will be returned from the function. So we used a closure in this case to quickly evaluate logic without having to do a separate function call, which allows us to keep our code clear and concise. So that is one of the ways that a closure really shines when we use iterators. We're able to quickly and efficiently have short and concise logic in order to evaluate values coming into our closure. But now, what if we wanted to create our own closure? Our own iterator. So we'll create another struct, and we'll call this one a range, and we'll give it a start, and then it'll be unsigned 32, and then we'll give it an end of unsigned 32 as well. And now remember, we have to implement an iterator for range, and now we need to implement the trait. So we're going to have type item, and it's going to be unsigned 32, and now we need to implement next. So we'll have a mutable reference to self, and it's going to return an option of self item. Is that how it was? Yes, self item. And here we will say if self.start is greater than or equal to self.end, then we want to return none. Otherwise, let result equal sum self.start, and then self.start, increment it by 1, and then give us the result. So to check to make sure that this works for us, let's create a range, and we'll give it a 0 to start, and then we want our end value to be 10. And then we'll say for r in range, we want to print out the iterator, and we want this to be a little r. So now if we run this, and we now see 0, 1, 2, 3 all the way to 9, which is perfect. So now we know that our iterator is working for our range struct. So I also said that we should get some default traits, or excuse me, some default methods once we implement in the next function. So let's check to make sure that we did that, and then that would also prove that we got our implementation done correctly. So we're going to call range.filter, which is a function given to us if we implement next correctly. We're going to pass in a parameter, and we only want values where when that parameter modded by 2 equals 0. So that means when the values divided by 2, our remainder is 0. And then we want to collect, that way it is stored inside of our vector. And now if we print this vector out, we would expect all the values that when divided by 2 equals 0. And we see that we get 0, 2, 4, 6, 8, which is correct. So that's really all there is to it for iterators and closures. We see that we can use closures to allow us to easily perform logic on values inside an iterator. In the next section, let's continue on and start learning about smart pointers.